Hi everyone, welcome to the Swift Arcade. I'm your host, Jonathan Rasmussen. Data flow is one of those things that when you get into SwiftUI, it can be really confusing and overwhelming. It's completely different from how we do in UIKit. And in this episode, I want to show you 6 different ways you can flow data into your SwiftUI apps and make sense and give you a reason to use them all. So come on in and let's see how it works. Okay, so when it comes to flowing data into a SwiftUI app, we've got over 6 different ways we can do it. And it's largely broken down based on whether or not your data is a value type or a reference type. If it's a value type, that means it's something like a struct, an enum, or a tuple. It's a plain old object. We can use a property, state, or binding to pass and flow our data in. If it's data that we need to share with other views in the app, however, we use a reference type or a class. And here it's going to be an observed object, a state object, or an environment object. Now, before we get into each one of those, let's just quickly review how data flow works in SwiftUI because it is a bit different. And the first thing to understand is that views are a function of state, not a sequence of events. Okay, so what does that mean? Instead of having a user do an interaction and then directly update our view through an IB action, in SwiftUI, when there's an action from the user, we change or mutate state. That changed state is what drives or updates our view and causes it to re-render itself. That's how data works in SwiftUI. So instead of reacting to what's going on in our UIs directly, we're taking those actions, manipulating state, and that is going to update and re-render our view. Now, the best way to see how this works is to see how a view is created. And in SwiftUI, views are structs. So let's head over to the arcade now and take a look and see how this all works. Okay, so the first way we're going to look at passing data into a SwiftUI view is using a plain old property. And that works just like this. Here we've got a player view, which you'll note is a struct. All views are structs in SwiftUI. And we can set a property on that struct because structs accept properties. We'll set it to a value of true. And then we can use that property in our view to do something interesting, like either display a pause or a play circle. So when we create our content view down here, we just simply pass in the state of our property, in this case false. But we could also pass in true. And we could change that image and change the state and have it render itself based on the value of the property coming in. So that's the simplest thing we can do, and it's great until we actually want to change the value of this property. Because in structs, what do we know? Well, structs, of course, are immutable, meaning we can't take the property of the struct and change it. So you cannot change a mutating member on self, because that's just not how structs are a value type. So we've got a bit of a problem here. We've got a property in our struct. We want to change it, but we can't. So what do? Well, this is where we go to the second type of property that we've got to work with, something called state. State is the property wrapper we want to use when we want to keep track of transient state owned by the view. So what we've done here is we've taken our plain old property is plain. We've added a state property wrapper in front of it. And now this view is going to track the state of this property. So we still create it the same way, but now when we use it down here, if this state changes, this view is going to remember its state and just continue to render the UI according to that state. Now this in itself isn't that interesting. What's more interesting is when we combine it with another property wrapper called binding. Binding is a read-write without ownership, and it derives its value from state. And it works like this. Let's say we wanted to add a subview to our app, a label with a switch button down here, and we wanted this switch to affect or change the state of our play button up here. How could we bind the value of that property up here is plain to the value of that switch down here? So when it changes like this, that will change also up there. And the way it works is it binds state properties to views and subviews using this $sign prefix, where it passes in a binding, and now this state is bound down into these subviews. So in this case here, we have another struct, a play button view. We want to bind isPlain down into this subview here. So to do that, we define our property as before, isPlain_state. We pass it into play button with this $, and then we use this other property wrapper binding to bind isPlain in this play button subview to the value of the property in the parent view here. So what we're doing here is we're taking isPlain and we're passing it into play button, this element here, and we're also binding it to the toggle is here. And you'll see this a ton in SwiftUI. This is how we often bind primitive states and track them in our subviews to controls in our view. So in this case, isPlain is bound to toggle. So now these are bound to that property. I can come down here in the switch and change the value of the switch, and that property will change and update all its subviews. I can also tap the button here, and because those properties are bound, I am now changing the value of the toggle here. So that is how state and binding work together to enable you to track transient state in your views. Okay, so that's 3 ways that we can basically pass data into a view using value types. Property for read-only immutable data, state for transient data owned by the view, and then we can bind them using that read-write without property ownership, and we derive that value from state. That takes care of our value types. When we want to share data with different views and different hierarchies across the app, here we need to flip to a different type of data flow, one that's based on references. Let's now take a look and see how observed object, state object, and environment object work. So the reason why we need to look at a slightly different type of property wrapper is when we're working with external data. Because sometimes data changes externally to our views and we need a way of being notified. Now, as good as structs and primitive types were for this simple data flow here, where the user does an interaction and we update the view, they're not great at sharing data because structs are value types. That means their value is copied every time they're passed from one function to another. What we need here is something so that when there's an external event coming from either a publisher or a notification or something, we need a way of sharing that state across all of our views. And this is why we need to shift and move to a class, because classes are reference types, meaning we can define the data in one place and then pass that reference everywhere else. So to facilitate this passing of data throughout our app, the authors of SwiftUI have created a new protocol called the Observable Object Protocol. What this does is this is a protocol that basically has a publisher where every time a property changes, it will broadcast that event out into the app and we can register and listen for that. So you'll note here in this protocol, this is a protocol that forces anyone implementing this protocol to be of type class. It's going to broadcast events will change. And this is the protocol that these 3 property wrappers use, observed, state, and environment object, to basically listen for notifications throughout your application. Let's take a look and see how observed works. So basically, if we have a struct or some data that we want to share throughout our application, in this case, say we want to publish notifications about book, we would take our plain old struct called book with a title and author, and we would mark those properties as published. What that means is we're going to publish notifications throughout our app whenever these change. And anyone listening or having registered themselves for this object as an observable object, they're going to be notified. So what that looks like is when we build this out in our app, we're going to build a book. We're going to make it of type class. It's going to be observable. We're going to have our published values here that we're going to publish. And then you'll see we can just pass that object to all of our views and our subviews, and they will be updated whenever that's changed. So to use an observable object, we first of all take our struct, we mark it up as class, and have it implement that observable object protocol. Then we say, here's the properties we'd like to publish, in this case, title and author. Then when we create our view, we inject that into our view like this. We define an observed object saying, hey, this is the book that I want to be notified about or I'm going to be publishing state on. And then any subviews that want to use that, we pass down here through the constructor. So our detail view here we explicitly pass it in. And now this view also has access to book, but it may not choose to use it. It's not actually doing anything here with the book. It's going to pass it to another child subview. And down here, it also is marked up where it can use the book. And here it can actually take the book and publish or share or update its view however it wants. So you'll note here that the way we get this into our views is we define the book. This is what's going to be published. We pass it in and we pass it down through all of our subviews here. So it's a little bit of a kind of a tighter coupling. We have to pass this into every subview here where we'd like it to be used. And that's just a very simple example of how observed object works. Now, just the one thing to understand with observed object is that when its data changes, it invalidates the view wherever it's used and it re-renders the view. So just note that what that means for us is if book ever changes, all of these subviews re-render or redraw themselves. And that's fine. We can just pass down our data. We want these views usually to re-render themselves. That's what observed object does. Next, let's take a look at a very similar one called state. Mechanically, state works just like the observed object. Here we still define our observed object the same way. We simply replace the word observed object with state object, and we can pass it down just like we did before. It's that easy. So coming over to our view here, instead of an observed object, we could change that to state. And it's going to behave exactly the same way. No change in mechanics, no change in anything except how it's actually used. So here, I just wanted you to see mechanically how it's exactly the same. You can just swap the word observed object for state. It'll render exactly the same way, passing in the state object along the way. Now you might be wondering, well, Jonathan, what's the difference then between state object and observed? Okay, for that, I've just got to show you a slightly more complex example. Let's see what the difference between state and observed objects are now. Okay, so what we have here is a Swift app, SwiftUI app, where basically in our content view, we have something called a search manager. And all this thing does is as you type music in here or whatever you're searching for, it updates the label down below and basically passes the state from the top here, the search bar, down to this subview through something called a search manager. That's an observed object, which we can pass down our message or the content of this text field down into here, and these views will re-render themselves, and we're going to do it all with observed object. Now watch what happens if we run the app and say we actually start playing some music. So hopefully you can hear some music playing in the background. These are bound together. I'm going to start typing up here, and look what happened. It's like my music player lost its state, or it got changed. It stopped playing, and I didn't want to do that. This is one of the side effects of using observed object. To fix this, what we need to do is we need to come down here into the search view, and instead of using our player and binding it to observed object, watch what happens when we change it to state. If we run the app now, and we let it fire up and start playing the music, as I start typing in that text field, it keeps playing. In other words, it remembers its state regardless of what I am doing down here, and it's good. It's kind of working the way I want it to. This is the main difference between state and observed object. And let me show you what's going on here. When you use observed object and pass it down into your subviews, these views get invalidated or re-rendered every time the value of that property object changes. So that was going on when we started playing the music and then we changed the value in the text field. This view got re-rendered. You can think of it as getting invalidated, re-rendered with its new initial state, playing the music, And then as soon as that changed again, it lost its state, it blew itself up, re-rendered, and it continues re-rendering or invalidating itself from a clean slate every time. Sometimes that's what you want, and that's perfectly okay. But the difference between observed object and state is that when you use state, that subview will now track the state of the object separately from what you saw there. It doesn't recreate it or invalidate it every time. So that's why we can go play, pause, it'll remember its state, but it won't blow itself up or re-invalidate itself because the view down here is maintaining the state for itself. So that's the big difference. If you want to re-render your view completely with every change, use observed object. If you want that view to maintain the state for itself and remember its state and still update itself but not blow itself up, then use state object. That's the main difference between observed and state. So observed object invalidates a view whenever the observable object changes, and state object, SwiftUI owns that view. It does not get invalidated with every property change. Okay, now let's take a look at our very last one, the environment object, and see how that works. Okay, so environment object works very similar to state and observed. The big difference is the reduced coupling and also the way you inject it in. Here we have our same book preview. Note how we inject the book object into our content view. Here we do it using environment object, passing in the book, and then by doing that and passing it in, all of our subviews instantly get access to it. We don't need to define an environment object here as a property wrapper, we just get it. So the fact that it's passed into state view, we don't need to define it there. It automatically gets passed into detail header. We don't need to define a receiving property wrapper there. We can go all the way down to the subview where we actually want to use it and then just instantiate it or pull it out of the ether with environment object like this and then use it there. And that's really the big difference between environment and state and the others. With environment, we can inject it at the top of our view hierarchy and pass it all the way down without having to reference it explicitly in every intermediary subview here. Inject it at the top, pull it out when you need it. It's really convenient. So you can think of this as very similar to state or observed object, but with way less coupling. You don't need to pass it down here through every subview, which can be a lot more convenient and make it easier to use. There is one more environment property that we're not going to talk a lot about here, but it can be confusing also. There's something called an environment, which looks like environment object, but it's subtly different. Environment object is when we have data we want to share and pass around our subviews, that's fine. Environment is kind of a key value pair repository that SwiftUI uses to let you pass kind of iOS-ish view-specific information like size category. Here you can set the environment size category, and you can make your app have that extra large font, and you can use that in your previews just to see what your app looks like or to change the configuration throughout your app instantly. That's the difference between environment and environment object. This is one we control and use a lot of, and this is one for setting environment settings in SwiftUI. Okay, next let's take a look and see how to choose which one of these property managers in our apps. The sheer number of options we have can make this really confusing and overwhelming at first. And I'm still coming up with a language myself to explain to myself how I would choose one of these over the others. But I think a good place to start is just to start mechanically by understanding the difference between value and reference object. If we have a simple view that we just want to maintain state on at a very primitive level, in other words, we can use value types like bools and strings, come down here and see if you can't maintain that with the state property wrapper. And then if you want to pass or bind that to either controls in that view or subviews, do it with binding. So this is a really nice area to work in if you've got value types, very simple transient data you want to track and just put it in your view. That'll bring you down here to state and binding. If you have more app-wide data, and these are results that either you fetch from the back end, or this is something like an account or a user that you want to broadcast throughout your app whenever that changes, then we're going to need to come over here to reference and work with classes. So remember, classes are great because this is what enables us to broadcast their state throughout our app. The main decision point here for me is the data I'm working with here local to the view or more global in nature? If it's local, I'll come down here and I'll either use state if I want that state to be maintained and controlled in the view, or if I want it to invalidate itself and re-render itself every time, I might use observed. So just remember that example we looked at. If you want to invalidate and re-render it every time, use observed. If you want the view to maintain that state and remember its state as it's being updated, reach for state. And then in those cases where it's really hard to reach sometimes, maybe I've got a lot of subviews very far down and I want to broadcast a state change down there. That's when I'll reach for environment. It's got a lot less coupling. I won't have to pass the observed object every state down the way. I can just broadcast it with environment object, pull it out when I need it. A really nice way to get to those harder to reach places. And right now, that's the best way I can describe how to choose which property wrapper for your Swift data flow. If you'd like to read a text version of everything you've seen here, come on over to my repo, JRasmussen SwiftUI, and under SwiftUI data flow, how it works, you'll see a text version of everything we've talked about here. Feel free to grab the source code, play with it yourself, and just see if you can't get some better rules of thumb around where and when to use each of these different types of data flow in your SwiftUI projects. Okay, well, there you have it, folks. That's currently my best advice on how to choose the right property wrapper when you're doing data flow in SwiftUI. Admittedly, I'm still figuring this out myself. What I really need to do now is go build some apps, try these things out to get a better feel for how and when to use them. It can be overwhelming at first, but hopefully by just taking some of these examples, playing with them yourself, you get a better feel for how and when to use each. It looks really tough at first, and I'm watching the WWDC videos, it completely blew me away how much there was going on. But if you just start with small steps, break these things down, hopefully it'll make more sense, and soon you'll be flowing data into your SwiftUI like an expert. Anyways, hope you enjoyed that. If you want to continue this journey, do hit like, do hit subscribe, come back, and we'll continue exploring all things really neat, fun, and cool in SwiftUI and other iOS topics. Okay, thanks so much for coming, everyone. We'll see you next time. Bye-bye.